In calculus, I think it's really beneficial to have a working knowledge of some of what the parent functions look like. So I made a graphic organizer. It has 9 different graphs. And what I'd like you to do is go through and fill out all the information for each graph. We are going to go into transformations next, and having this graphic organizer completed is going to help you a lot. So I thought I would walk through a couple of these with you to show you exactly what I was expecting. So I thought the first one that we would do together could be f of x cubed. Actually, let's do f of x squared. So this is a quadratic function. The parent function is f of x equals x squared. I'm not looking for you to update anything in the first 2 columns. I do want you to draw a graph, and I thought that a table would help you draw that graph. So I put in x values that I want you to evaluate at. So if x is -2, x squared is going to be 4. -1 corresponds to 1. 0 corresponds to 0. 1 squared is 1, and 2 squared is 4. So if I come back to my graph, I'm going to do all of my graphs as 10 by 10. So the scale is 1. So I'm graphing 0, 0, 1, 1, 2, 4, and the same points on the reflective points. Okay, here's one thing I noticed about graphing. People will see this and then they'll just shoot the graph off wherever. You need to see if there are any other points in this viewing window that are actually on the graph. So I would go out one more, even though it's not in my table. So 3 squared is 9. So I know this point here. And -3 squared is 9. You want to be, it is a sketch, but you want to be as exact as you can be. Okay, so my quadratic function is a parabola that looks like that. Okay, what I meant by being careful about the graph is what I'll see is a lot of people will do the 5 initial points, and then they'll do something like this. Okay, I see something like this a lot on the test. So you have the graph that's pretty much correct here, but then the graph goes way off here. You are telling me by doing this that this point is on the graph. So this would be the point 4, 7. But think about it. If I put in 4 for x, 4 squared is 16. It should be way up here on the graph. Okay? So I think, like I said, I want you to be exact. I want you to be mathematicians who are exact. So you want to make sure you find as many points in the viewing window as you can. And obviously, in between, it's probably not as exact as it could be, but it doesn't go outside of where it should. Okay, so please just be careful of that. So next, I would like you to determine the domain. I am going to write all of these in interval notation. The domain for our quadratic is all real numbers. So that is -infinity to infinity. I'm not opposed to you using the real number symbol. I'm just going to do interval notation for consistency. And next, I want to look at my range. So for my range, I notice that there are no negative values for y. So I can see that my range goes from 0, 0 is included because there's a point at 0, up into infinity. So now I have the graph, I have the equation, I have the graph, I have the domain and range, I have a table with some of my key points. And now I want to work a little on some characteristics of the graph. So I want to think, where is this graph increasing? This graph is increasing on the right side of the graph. At any turnaround point or point of inflection, the graph is neither increasing or decreasing. We'll go over that more, and don't get too nervous about this column. Just do the best that you can today. So this graph is increasing from 0 to infinity. Right here, the graph is getting, the y values are getting larger, and our graph is decreasing from negative infinity to 0. This graph has an absolute minimum. It has a point that is the lowest point on the graph. So it has a minimum at 0, 0. And it does not have an absolute maximum, so I am going to write in none. Okay, so now I have I have all this information about a quadratic function. So next, let's work through the rational function together. So for my rational function, negative 1 over negative 1 is negative 1. 1 over 1 is 1. So I know that I want to have the point negative 1, negative 1. I also know I want the point 1, 1. Okay, so what happens if you have no idea what this graph looks like? You can go to Desmos. Sorry, I had some technical difficulties. So you can go to Desmos and you can graph it, and you can type in y equals 1 over x and see the shape of this graph. Okay, so I see, because I've done this and I'm comfortable with it, that I have a vertical asymptote. So I have a vertical asymptote at x equals 0. And I have a horizontal asymptote at y equals 0. And then I want to think about some other points, okay? So at 2, I'm going to be at a half. At 3, I'm going to be at a third. Okay, so I'm getting closer and closer to the y-axis. Similarly, if I let x be a half, 1 over a half is 2. 1 over a third is 3. Okay, so my graph is going to look like this. Okay, arrows at both ends because it goes on forever. And similarly, if I think about other points, at negative 2, 1 over negative 2 is negative a half. 1 over negative 3 is negative a third. 1 over negative a half is negative 2. Okay, so my graph looks something like this. So my domain this time, right? My domain is basically that x cannot be 0. Because think about it, 1 over 0 would be undefined. So in interval notation, that's negative infinity to 0 and 0 to infinity. And for my range, if I have a horizontal asymptote at y equals 0, then y cannot be 0. So again, in interval notation, that's negative infinity to 0 and 0 to infinity. So next, my characteristics. Is this graph ever increasing? If I start here, I am decreasing and I'm decreasing. So this is never increasing. And then my graph is decreasing from negative infinity to 0 and from 0 to infinity. Okay, notice at 0, there is no graph, right? So 0 can't be in my decreasing interval. This does not have an absolute maximum, right? Because the graph goes all the way up to infinity. And it does not have an absolute minimum. And we talked about how it has a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. Okay, so do your best, complete the graphic organizer, spend an hour on this, and then we can continue to build on it.